Finally, we are now at the lesson where we are going to start using calculations. So in earlier lessons with this electricity chapter, I would have showed you 3 different triangles which had different letters and we could make different formulas. Remember that? So for example, one of them was something like this. Another one was something like that. And the other one was something like that. Now, in this chapter, or now when we start doing these calculations with electrical circuits, the biggest one we are going to be using is this one over here. So let's ignore these ones for now. Okay, let's actually just get rid of them completely. Of course, we need to still know them, but when we are looking at electrical circuits, this is the most important one now in grade 10, grade 11, and grade 12. So let's just recap how these formulas work again. So if you are looking for V, because V is at the top, then you just multiply the 2 that are at the bottom. Okay, so that's a formula we need to know. If we are looking for I, then you could say I is equal, and then you've got V at the top, R at the bottom, V at the top, R at the bottom. And then if you are looking for R, then you would say V at the top, I at the bottom. Okay, so these are the 3 formulas that we will be using in this lesson. Now, this lesson is going to start off pretty basic, where we've got things like this. But then it's quickly going to start getting more complicated, where we have series circuits, and then we're going to have parallel circuits. So stay tuned for all of it. It's going to get more difficult as we go along. So here's our first question. Now this one says determine A. Now A is a ammeter, which is current. So if we look at those formulas with the V, I, and R, so we need to know that when they're asking you to calculate A, then you need to remember that A is current. So that's the I. So we could then say that I is equal to V over R, because that's what you get if you use this formula. So we need a voltage value. Okay, so we've got a voltage value of 6. Now, it's not going to be this easy, but I'm just building you up from the basics. Now, this voltmeter is connected to this resistor. So this V and this R, they can go together. So you've got to look out for that. And so that's going to give us 6 divided by 3, which is 2 amps. And so this would be 2 amps. Okay, so that's quite easy. I understand that, but we're going to make it more complicated as we go along. Here's the next one. So the first question says determine A. Now, A is a current, so we know that that's I equals to V over R. Now, you can't just choose any V and any R. For example, you can't just choose this V and this R. No, they need to go together. So this V is connected across this resistor, okay? And I didn't mention this in the previous slide, but remember that resistance is the symbol over here. So this is a resistor. So these 2 are allowed to go together. So if we use I equals to V over R, we could say that I is equal to 6 over 3, and that would give us 2 amps. Okay, so that means we have 2 amps over here. Now, the next question is determine V. Okay, so this is a voltmeter over here. So if we use our triangle again, so V, I, R, then to calculate V, you multiply I and R together. So what that means is we need some type of current, okay, and we need some type of resistor. So we can see which resistor we need to use because we're looking at this voltmeter, which is connected across this resistor. So we know what the resistance is, but we don't know what the current is. We don't have a current value. However, we have learned that when you are in series, when the electricity flows like that, then the current remains constant. Remember, in series, current remains constant. So that means then that this is also going to be the same as this current value over here. Because if you have 2 amps over here, then that 2 amps is going to flow all the way through. So now we know the current as 2. We know that the resistance value is 2. And so this voltmeter will be 4 volts. 4 volts. All right, so here's our next one. So they want us to determine A. Now remember, A is a current. So if we use our formula, V IR. Then to calculate the current, which is I, you're going to say V over R. So they want us to calculate this value over here. So we need to find a voltage and we need to find a resistance. Now the only voltage we have is the 6. But if you look at that 6 over there, that is connected over here and over here. So the resistors that it is connected over is both of these. So if you want to use that voltage of 6, then you need to use these resistors. Now remember, these resistors are in series. And we've learned in previous lessons that when resistors are in series, you just add them together. So you just say 3 plus 9. You don't have to use that weird R parallel is equal to 1 over R1 plus 1. That's only when they're in parallel, which we'll look at a little bit later. But in series, you just add them together. Okay, so that's going to give us 6 divided by 12, and that's going to give us 0.5 amps. So here's our first proper circuit example now. So the first question says calculate A1. Okay, so from our formulas, which we have over there, they want us to calculate current. So we know that current is equal to voltage over resistance. Now you got to be careful with which voltage you actually go and use. So you got to be careful with which voltage and which resistor you use. They have to go together. So we don't know what this voltage is. We don't know what this voltage is, but we do know what this voltage is. Now this is the battery voltage. Okay, that is your battery. So if you use the battery voltage, okay, then which resistors do we need to use? Well, the battery covers everything. So then you will use all resistors. So we need to go add up all of the resistors, but we need to be careful. Are we in parallel or are we in series? Because in parallel, you add the resistors differently to if you are in series. Remember that in series, you just add all of them together. So you just keep adding all of the resistors. But then in parallel, you've got that weird formula that does something like this. Okay, so we need to go check, are we in series or in parallel? Some of you can identify it immediately, but if those of you that are struggling, let me quickly try explain. So we know that the electricity starts over here, and then it flows through the circuit like that. So can you see that the path never changed? We didn't split up like we've seen in previous lessons. So this is a series circuit. So the total resistance would be the 2 ohm plus the 1 ohm, and that would give you 3 ohms. So that is our total resistance. So we know the voltage and we know the resistance. So we can now say 3 divided by 3, and that'll give us 1 amp. So that is the current flowing in the whole circuit, because we used all of the voltages, which is the battery, and we used all of the resistors, and so that is going to give us the current in the whole main part of the circuit. So that means the current here will be 1 amp, and over here 1 amp, and everywhere 1 amp. It will be 1 amp over here, 1 amp over here. Everywhere the current will be 1 amp. So here we can say 1 amp, here we can say 1 amp, because we've learned that current in series remains constant. The next question asks us to calculate V1. Okay, so V1 is over here. So V1 is connected across this resistor. So when you use the formula for voltage, which is V equals to I times R, you're going to use the current that goes through that one, which is the 1 amp, because the current is the same everywhere. And then you're only going to use that resistance value, because this voltmeter is only connected across that resistor. And that would give you 2 volts. Okay, so that's 2 volts. The last question says determine V2, which is this one over here. So check this out. We've got the current and we've got the resistance for that particular voltmeter, which is only connected across there. And so you could say V is equal to I times R. And so V is equal to 1 times 1, which is 1 volt. For those of you that are curious, notice how these 2 voltmeters, when you add them together, 2 plus 1 gives you the battery voltage. That is something we have looked at in previous lessons. For those of you that are interested about that. Okay, let's go to our next example. So here's our next example. So the first question says calculate R. Okay, so from our formulas, we've got this over here. So if you want to calculate R, well, that is going to be R is equal to V over I. So if you look over here, R is connected between this voltmeter. So we're definitely going to use that 6 volts over there. So we have the voltage. Okay, now we need a current. They've told us that the current here is 3 amps. Now because this circuit is in series, have a look here, see that it's in series? Well, what that means is that the current going through this resistor is also 3 amps. So we have the current. And so then if we had to go work this out, you're going to end up with 2 ohms. Remember, that is the unit of resistance. The next question says calculate V2. Okay, so V2 is over here. So we know from these formulas that to calculate voltage, you have I times R. Now, we know that this voltmeter is connected over here. So it's connected across this resistor. So that's the resistance that we would use. So we've got the resistance as 1. Now we just need the current that is going through this resistor. So we know that the current in the main circuit is 3 amps. So that means that that current all the way through is going to be 3 amps. So we can just say 3 over there. And if you had to calculate that, you're going to end up with 3 volts. So V2 would be 3 volts. Okay, so let's just fill that in there as 3 volts. The next question says calculate V. So there are a couple of ways that you could do this one. Okay, one of the ways is to remember the formula that I've showed you in previous lessons, which says that the voltage of a battery is equal to the sum of all of the voltages in series plus the parallel branches. Now, we don't have any parallel branches, so we can just ignore that. So the voltage of a battery is the sum of all of the voltages in series. That would be 6 volts plus 3 volts. So that would be 6 volts plus 3 volts, which is 9 volts. That's one way to do it. The other way you could do this question is you could use a formula. So you could say voltage is equal to current multiplied by resistance. Now, if you are looking for the battery's voltage, remember what I showed you in the previous example, if you are using the battery voltage, then you must use all the resistors. Then you must use all of the resistors, and you must use the current that is part of the main circuit. So that means you would use this resistor over here, which is 2 ohms, and you would use this resistor over here, which is 1 ohm, and because they're in series, you would plus them together. So the total resistance is going to be 2 plus 1, which is 3 ohms, okay? So then the voltage would be the total current multiplied by the total resistance, and that would give you 9 volts. So it's the same exact answer. The last question for this particular example says determine A2. So A2 and A1, or this one, are going to be exactly the same because this circuit is in series, and so all of the current stays the same. And so that will simply be 3 amps. So here's our next example. So this one says, the first question says determine A1. Okay, so from our formulas, which from our triangle of formulas like this, to work out current, you need to know voltage over resistance. Now, what voltage do we use? Well, we don't have this voltage, we don't have this voltage, but we do have this voltage. So if you are going to use this voltage, then you need to use this resistor, because this voltage is connected only across that resistor. So you're going to say I is equal to 4 over 2, which is 2 amps. But now some of you might say, yeah, but Kevin, doesn't that mean that the current going through this resistor is 2 amps? Yes, that is correct. But we know that current in series is the same everywhere. So if we've just worked out the current over here, well then that is also the current over here, over here, over here, everywhere, because current in series stays the same. So we can say 2 amps over here and 2 amps over here. The next question says calculate V2, which is over here. So to calculate voltage, you need to say current multiplied by resistance. Now we know the current because current stays the same everywhere. And so we also know the resistance that is connected between that voltmeter. And so we can just say 2 multiplied by 1, and that's going to give you 2 volts. Okay, so we can say 2 volts. The last one for this particular question says determine And by the way, we're going to get to a whole bunch of parallel examples coming up now, and we're even going to do an example that has a parallel and a part that's in series. Okay, and then we would be done. So it says calculate the voltage. Now, once again, there are two ways to do this to calculate the battery voltage. So you could either use this formula again. We don't have any parallel parts. So you could just say that the voltage of the battery is equal to the sum of all of the voltages in series. That would be 4 plus this one, which was 2 volts. So that would be 4 plus 2, which is 6 volts. Your other option is to use the voltage formula, which is V equals to I times R. And so your current in the main circuit is 2 amps, which we already found. And then you would have to use the total resistance. Because you're using the battery, you have to use all of the resistors. So the total resistance would be 2 plus 1, which is 3. So you could say 3, and that would give you 6 volts. So whether you use that formula or that formula, you're going to get 6 volts for the battery. Some teachers might call the battery, the voltage of the battery, the EMF. Okay, I haven't mentioned that. I actually forgot I haven't mentioned that at all. So yeah, EMF is another name for the voltage of the battery. Okay, so here's an example where we're going to be having a parallel scenario. Okay, so the first question says calculate A1. So A is a current, right? So that's I. So to calculate current, you say I equals to V over R. So we need a voltage. Now there's no voltage here, no voltage here, no voltage here. However, we do know the battery's voltage is 2. Okay, so if we use the voltage of the battery, then we need to use all of the resistors. Remember that. If you use battery voltage, then use all resistors. But you need to understand if you are in series or in parallel, or sometimes, as we'll see later, you're going to have series and parallel, or let's rather say parallel and series. So if we go look at this circuit, we can see that it is in parallel because some of the current's going to go this way and some of the current's going to go this way, and then all of the current will resume like that. So this part is in parallel. Do we have any other resistors? No, we only have those two, so we need to go combine them in parallel. So the way that you do that is you say 1 over R parallel is equal to 1 over 2 plus 1 over 6. Then you're going to go type that on your calculator, and that'll give you 2 over 3. Then you're going to flip both of these upside down, so you end up with R parallel is equal to 3 over 2, which is the same as 1.5 ohms. 1.5 ohms. Okay, so now we know the voltage. We're going to use that, and we know the total resistance, so we can go work out the current. So we can say 2 divided by 1.5, and to 2 decimals, that would give you 1.33 amps. So now we can use that current for the rest of the lesson, 1.33 amps. And let's just fill it in over here as well. Okay, the next question says calculate V1. Now, V1 is over here. Okay, so now this is important. We know the resistance for V1. V1 is connected across this resistor. So we know the resistance, but we don't have the current. You cannot say that this current is the same as this current because this part is in series, this part is in a different pathway, so the current is not the same. So this formula actually won't work. What we're rather going to do is remember this formula, which tells us that the voltage of the battery is equal to the sum of all of the voltage in series plus the parallel branches. Now, this circuit doesn't have any series resistors, so there's no voltages in series, so we can ignore that. So then we can just say that the battery's voltage is the same as the total parallel, the branches in parallel. So the voltage of the battery is 2. So we can say 2. And so the parallel branches are each going to be 2. So that means that this one is 2, this one is 2, and this one is also going to be 2 volts. So there we've got the voltage in there we've got V1 as 2 volts. Now the next question says, what is V2? So V2 is also 2 volts. We've got that one. The next one says, what is A2? Okay, so A2 is over here, so that's a current. So current is equal to voltage over resistance. Now, you've got to be careful. This current, ammeter, is connected on the green pathway. It's only the green pathway. So you need to look at on the green pathway. So voltages and resistors on the green pathway. So here we've got a voltage, and it's connected across this resistor. So we can use those two. So we could say 2 divided by 2, and that'll be 1 amp. Okay, so this is 1 amp. The next one says calculate A2. Oh no, that's the one we've just done. The next one says calculate A3, so that's this one. Now there are multiple ways that you could do this one. You could either use I equals to V over R, and you could use the 6 and the 2. Okay, let's just try that. So I is equal to V over R, and so the voltage is 2, and that 2 is connected across the 6 ohm resistor, and that'll be 0.33 amps. Okay, that's one way to do it. The other way is to remember what we said in previous lessons like this. So we learned that the sum of currents in parallel is equal to the current in the main circuit. So the current in the main circuit is A1, so that'll be the same as the sum of the currents in parallel. So that's A2 plus A3. So that would be 1.33 is equal to A2, which is 1, plus A3. Now, if you had to go calculate A3, you would end up with 0.33 amps, which is exactly what we got over there. So we only have 2 more examples now. All right, so well done for making it this far. We've just got this example, which is another parallel one, and then we've got one over here, which has a parallel or a series and a parallel combined. So the first question here says calculate A2. Okay, so if we look at the formulas, we know that to calculate current, we could try using V over R. So let's see what voltmeters we have. Well, A2, if we look carefully, we know that current flows like this. Then when it gets here, some of it would go this way, and the rest would go this way. It would then combine and go like that. So if you're calculating the current that's going through A2, well then you need to be only looking at this branch over here. So if you look at the voltages in that branch, we've got this one over here, and that is connected to this resistor. So those are going to be perfect. So we can say 3 divided by 3, which is 1 amp. So that doesn't mean this is 1 amp. No, that means this is 1 amp. Okay, so that's done. Determine V2. Now, V2 is over here. We know that in parallel, all voltages are the same. All voltages are the same in parallel. So V2 is also going to be 3 volts, because this path is 3 volts. So this path would be 3 volts, and this would also be 3 volts. The next question says calculate A3. Now, A3 is over here. So we could use I equals to V over R, where the voltage in that pathway is 3 volts, and the resistance in that pathway is 6. And so we could get 0.5 amps. So 0.5 amps. The next question says calculate A1. Now A1 is here. Now there's multiple ways of doing this, but one of the easiest ways is to remember is that the sum of currents in parallel is equal to the current in the main circuit. So that means that A1, which is part of the main circuit, is equal to A2 plus A3. And so A1 is going to be equal to 1 plus 0.5, because that's A3, and so that's going to give us 1.5 amps. So A1 will be 1.5 amps. 1.5. Now, the next question says calculate A4, but now A1 and A4 are going to be the same because they are both in series, and so that is going to be 1.5 amps. Now, the last question for this particular question says the EMF. Now, remember, EMF is something I introduced a few minutes ago in one of the previous examples, is actually just the voltage of the battery. That's what EMF means. Okay? So there's multiple ways to do this question now. One of them is to use the formula for voltage, which is V equals to... Well, let me show you the easy way first. The easiest way would be to remember this formula over here, which tells us that the voltage of the battery is equal to all of the voltages in series. We don't have any voltages in series. And then it's equal to plus any of the parallel branches. So we can just say that the voltage of the battery is going to be equal to the parallel branches. And so we know that the parallel branches are 3 volts, 3 volts, and 3 volts. So we can just say that the voltage of the battery is 3 volts. Okay, now the other way you could have done this, it's a little bit longer, but it would work, and I want to show you so you can just see that it does actually work, is to use the formula for voltage. Now, because you are looking for the battery voltage, then you need to use the total resistance in the circuit and the total current in the main circuit. So we already know the current in the main circuit is 1.5. Okay, so we could say 1.5. Now we need to go get the total resistance of the whole circuit, which is only these two, but they are in parallel. So you're going to say 1 over R parallel is equal to 1 over 3 plus 1 over 6. And so 1 over R parallel is going to give you, so you just say 1 over 3 plus 1 over 6 on your calculator, and that'll be 1 over 2. Then what you do is you switch everything around, so it becomes R parallel is equal to 2 over 1, which is actually just 2 ohms. So then you could say 1.5 multiplied by 2, and that would give you 3 volts. Same answer. So we can say there 3 volts. Let's do one more example. So this one says, now this one's pretty awesome because we've got a parallel part where the current's going to go there, and then it carries on in series again over there. So we've got a bit of series and parallel with a device in series there. So the first question says calculate A2. Now A2 is over here, so that's not part of the main circuit. So if we look at these formulas, we know that current is equal to voltage over resistance. But now this current is part of the green pathway. So you can use this 3 volt, which is connected to this 3 ohm. You see it's connected across this 3 ohm over here. So you could say I is equal to 3 over 3, which is 1 amp. That does not mean that this is 1 amp. It only means that it's 1 amp over there. Okay, so we've got that one. Fantastic. The next one says calculate V1. Now V1 is over here. Now we know that parallel voltages, the pathways have the same voltage. So this pathway has a voltage of 3, and that means this pathway would also have a voltage of 3. So V1 would be 3 volts. This question says calculate A3. Okay, so A3, we could use I equals to V over R, and we know the resistance, and we know the voltage connected across that resistance, or that resistor. So we could say 3 divided by 6, which is 0.5 amps. So 0.5 amps. The next one says calculate A1. Now we know that the sum of the currents in parallel is equal to the current in the main circuit. So that means that A1 is equal to the sum of all of the currents in parallel, which is A2 plus A3. And so A1 is going to be 1 plus 0.5, and so that would be 1.5 amps. So A1 is going to be 1.5 amps. Now that's part of the main circuit, okay, which is the part in yellow. The next one says that determine V3. Okay, now we know the current going through here. The current going through here would be 1.5 amps because current in series is exactly the same. But the problem is we don't know this resistor. We don't have that resistor. So we're not going to be able to use I equals to V over R or V equals to I times R. That won't work. But what we can do is we can look at this formula over here. So we know that the battery's voltage is the sum of all of the voltages in series plus all of the parallel branches. So the voltage of the battery is 9. Okay, so we've got that. Now, the voltage is in series. Now we actually do have a voltage in series. It's called V3. And then the parallel branches, remember you only take one of them. So they're all going to have a value of 3 volts. This would be 3 volts. This would also be 3 volts. So you just take one of them. Okay, you don't take all of them like that. And then if you had to go solve for V3, you would get 9. And then you take this 3 to the other side. So it'll be 9 minus 3. And that would be 6 volts. So that is going to be 6 volts over here. Now, the last question says calculate the resistor. Well, from our formulas over here, we can work out resistance by saying that R is equal to V is at the top, I is at the bottom. And so this resistor is only connected with this voltmeter. So we could use that voltage of 6, and the current that is flowing through that resistor is 1.5, and that is going to give us 4 ohms.